Here's an introduction into some three-dimensional geometry. You have here a kind of a view of the major ones that we're going to be covering. We don't call it a cuboid, we call it a rectangular prism in our class, but all of these are three-dimensional solids. All of these on the left of this line are what we consider polyhedrons. They're made out of polygons or flat shapes that are basically made out of line segments. All of these three over here, the cone, the sphere, and the cylinder, all have curves, so they don't quite fit the definition of polyhedron. I want to go through a couple different pieces that make up these polygons, or the polyhedron ones, the one made out of polygons. So let's look at this cube, and we'll just kind of take it for example. If I have one flat side, like this front right here, that is what we call a face. The face are the flat polygonal sides of a three-dimensional polyhedron. So if we were to count up the number of faces on that, we would have a front and a back, a left and a right, a top and a bottom, and there would be 6 faces. Same thing for that rectangular prism that we talked about. You'd have a front and a back, a top and a bottom, a left and a right, and you'd have 6 faces. If you had that square pyramid, you'd have the square on the bottom. You'd have the 4 triangles going up to it, so you'd have 5. On that triangular prism down here, you'd have a front and a back triangle. Those are the bases. And you'd have 3 rectangles connecting them, so you'd have 5. And on this triangular base pyramid, you'd have a triangle on the bottom, and you'd have 3 triangles on the top coming up to the apex, so you would have 4. Wherever a face meets a face, for example, on that cube again, that front face that we're looking at, it meets that top face on what is called a line segment, and we call that an edge. So if I were to count up the edges on that cube, I would have 1, 2, 3, 4. Then I'd have 4 going back, 1, 2, 3, 4 going to the back, and then I'd have 4 going around the back, 1, 2, 3, 4. So I would end up with a total of 12 edges. I'd have 12 edges also on this one. On this square pyramid, I would have 1, 2, 3, 4 around the bottom, and then I'd have 4 that are going up to the apex, so I'd have 8. On the triangular prism, I'd have 1, 2, 3 on this base, 1, 2, 3 on this base, and then I'd have 3 connecting those 2 bases, so I'd have 9. And on this triangular pyramid, I'd have 1, 2, 3 around that triangular base, and 3 going up to the apex, so I'd have 6. I'll switch over to the rectangular prism. Where I have 3 or more edges that meet, they meet in one single point, and we call that point a vertex. So we're going to count up the vertices for these. The cube would have 1, 2, 3, 4, 5, 6, 7. You can't see where I'm drawing an 8. Would have 8 vertices. You might think about those as corners as the real world definition. The rectangular prism would also have 1, 2, 3, 4, 5, 6, 7, and 8. The square base pyramid would have a 1, 2, 3, 4 around the square, and then that special one called the apex, it would have 5. Triangular prism would have 1, 2, 3 around this front base, and 1, 2, 3 around the back base, so it would have 6. And the triangular pyramid would have 1, 2, 3 around the base and 1 apex, so a grand total of 4. Right now you're looking at an isometric view of this, so you're kind of seeing this 3D shape from an angle so you can tell it's 3D. Another thing that we want to kind of get an idea of is we want to be able to look at these in a 2-dimensional way. So we would look at them from the front, the side, and the top view. So let's just choose one. I'm going to choose the rectangular prism. If I looked at it from the front, I'd be looking at a rectangle about this size. If I walked around it to the side and stared at it from the side, it looks like I'd be looking more at a square. And then if I leaned over top of it, I'd be looking at what looks like a little bit wider rectangle than the front. Let's try that again with a little bit more interesting one. We'll try it with the cylinder. If we looked at it from the front, this is the one that people mess up. Well, they want to put a curve on it, but if you looked at it flat, it would actually just look like a rectangle, because it'd be a right angle and a right angle, and a right angle and a right angle, and parallel sides on the left and right, and parallel sides on the top and bottom. If you looked at it from the side view, you'd get the exact same rectangular view. And if you leaned over top of it, you'd be looking at a circle. Try one more. Let's do the cone, I guess. So think about the front view. If you're looking at it from the front view and you're looking at it flat, it's going to look just like a triangle. From the side view, if you walked around the side, it's going to look like that exact same triangle. From the top view, if you stared down at it, it would look like a circle. That takes us into our next skill, which is if we can think about these things in an orthographic way, as a flat way, we're going to be taking these things and chopping them. I like to think about the game Fruit Ninja, where you chop the watermelon. And think about it, if you turned that and then looked at that watermelon flat where you cut it, you'd be seeing a circle, right? And it'd be a little bit of green on the outside, and then a ring of white, and then a lot of red with black dots in the middle, just like you can see in that Fruit Ninja picture. That two-dimensional view of that three-dimensional item, once we have chopped it, is called a cross-section. And I'm gonna show you a little video. Hopefully, you can see this is a triangular prism. I'm spinning it so you can see it three-dimensionally, and then I'm gonna take a moment and I'm gonna slice it, hopefully parallel to the base. Now that view, that three-dimensional thing, you can see that the slice or the cut will be a two-dimensional triangle. If I were to chop it right there, just like in Fruit Ninja, and look at the wound, I'm going to turn that so you can see the wound flat, wouldn't it be a triangle? That means if I cut a triangular prism parallel to the base, because that's how I cut it, I would get the shape of the base. And that's really true for all these shapes that we're dealing with. If you cut it parallel to the base, you're going to get the shape of the base. It's true of pyramids and it's true of prisms both. Now I've got a square pyramid. This time I'm going to cut this one a couple different ways. First of all, I'm going to go parallel to the base. So like we just talked about, parallel to the base should give me the shape of the base. So as I rotate it, and you can see, if I am to chop it there, I'm going to get a square. So let's chop it. And I'm going to rotate that so you can see the actual wound that we did. Because once again, we want to look at it in a flat way, because you might say, well, it's still a pyramid. It is still a pyramid, but we're only looking at the wound of the cross-section, which was that square on the bottom. Now I'm going to try to go through the apex, perpendicular to the base, and look what you get. You get a triangle. So now I've cut it a little bit differently. Let's cut it apart. Oh, I guess I didn't cut it apart that time. That's kind of an introduction to how to do cross sections. You really just kind of have to think about those shapes. Basically, if they are pointy shapes like a cone or a pyramid, and it goes perpendicular to the base through the apex, you're going to get a triangle. If it goes parallel to the base, you're going to get the shape of the base. Now, you could cut that. I guess I'm going to maybe try that. Let me see if I do that. I'm going to try to cut it parallel to the base, parallel to the square on the bottom, but not through the apex, and look what happens. Since it was cut off before it got all the way to the apex, it ends up in a trapezoid. So when I cut it and rotate it, you should see that shape that it was cut in was a trapezoid. So that was looking at three-dimensional items in a two-dimensional way once you've kind of sliced them into a cross-section. This is a little bit different. It's taking a two-dimensional item and spinning it into a three-dimensional item. So here we have a rectangle, and we're going to be rotating this rectangle about this line segment right here. To predict what 3D shape will be made if I rotate that, leaving that blue line segment in place and rotating that rectangle around. For example, I'm going to rotate that around, leaving that blue thing in the middle like that. And I'm going to rotate it back here, and I'm going to show you that from a different view. Here's that rotation. And what shape did we end up making when we left that line segment still? We ended up with a cylinder. Now I'll try rotating this triangle. I want to leave this red line segment right here still. Sorry, I'll take that back. I'm going to leave this red line segment still. Ooh, that's not a very good line segment. Now I want you to predict what shape you're going to see when I make this three-dimensional. So So it looks like a triangle when I do this, but remember I'm rotating it around that red line segment. Then we'll change view just a little bit. We'll do that again. Ready? Now can you see what shape we made? We made a cone.